Okay, this is lesson 5.3. It's about binomial radical expressions. So we're going to add and subtract radical expressions, and then we're going to use the skills we did with those in order to multiply radical binomials, and then after we multiply radical binomials, we're going to use that to rationalize some denominators. So it's a lot of stuff to get to, so let's get started. So like radicals are radical expressions that have the same index and the same radicand. So only like radicals will be added and subtracted. So when I say like radicals, the thing underneath the radical sign has to be the same, and the index, or the little number on the outside, has to be the same. The coefficient that come in front does not have to be the same. So if we look at this list that I have, the 7 and the 4th root of 7 and the 3rd root of 7 are not like radicals because the index is different. The 4th root of x and the 4th root of x are like radicals. The 3rd root of z squared is not a like radical with the cube root of z. So z and z squared are not considered the same thing when we're looking at the radicand. The cube root of the square root of 3n and the square root of 3n are, you can have variables underneath of that, that's fine, but they have the same variable. Next we have 3 root 2 and 4 root 2. Those are like radicals. The 3 and the 4 are different, but those are coefficients. They're not indices. So they're allowed to be different and still have a like radical. 2 cube root 3 and x cube root 3x, not the same because one has 3x underneath, one has 3. And the last one, 4x squared z to the 5th, square root 18x squared y to the 3rd z to the 4th, and blah, 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 blah. But you can see if you look at it, they're both 5th roots, and they both have 18x squared y to the 3rd z to the 4th. So those are like radicals. So how do you add subtract like radicals? Well, it's the same way you combine terms in a polynomial. So you take those like terms and you treat the radical part as a variable, and then you add them. So if I have 5 cube root x minus 3 cube root x, I keep the cube root x the same. I subtract the 5 and the 3, I get 2 cube root x. So my next one, 2, is 4 root 2 plus 5 root 3. Those are not like radicals, so I can't add them. So I leave 4 root 2 and plus 5 root 3. You can't simplify it, so write it over again. Number 3, I have 7 cube root 5 minus 2 fourth root 5. Again, not the same index, so they're not like radicals, so you can't add or subtract them. So I leave it alone. I have 2 root 7 plus 3 root 7. Well, they're both root 7, so 2 plus 3 is 5, and that's 5 root 7. Then I have 4 root xy minus 7 root xy. I can do 4 minus 7, that's negative 3, so that's negative 3 root xy because they are the same. That's the same radicand. So adding and subtracting, it's very much like you add and subtract like terms in variables and things like that. But you got to be careful because you have to make sure you simplify before you add, because they might not look like radicals if they are like radicals. You haven't simplified yet. So an example, I have 6 root 18 plus 4 root 8 minus 3 root 72. Now those don't look like radicals because I have 18, 8, and 72 underneath. But in fact they are, and I'll show you why. 18 can be simplified. We can't take the square root of 18, but we can take the square root of 9, which is a factor of 18. So I split the 18 into 3 squared times 2, because it's 9 times 2. 8 becomes 4 times 2, so that's 4 squared times 2 squared times 2. And 72 is 36 times 2, which is 6 squared times 2. So when I do that, I can simplify by taking out all the things that are squared. So I have 6 times 3 root 2 plus 4 times 2 root 2 plus 3 times 6 root 2. Again, everything that's squared, you take away the square and you move it to the outside of the radical. Now I multiply the numbers on the outside. So I have 6 times 3 is 18, 4 times 2 is 8, and 3 times 6 is 18. So now I have 18 root 2 plus 8 root 2 minus 18 root 2. And if you look at that, see, when I simplify them, they are like radicals. They're all square root 2. So now I combine them together. 18 plus 8 minus 18 is 8. So when I add those three radicals expressions together, I get 8 root 2. After we add, the other thing we're going to do is we're going to multiply radical binomials. And these are radical expressions that have two terms that can't be combined. So for instance, if I have 3 plus 2 root 5 times 2 plus 4 root 5, those can't be combined. I cannot combine the 3 with the 2 root 5 because they're not like radicals. And I can't combine the 2 plus the 4 root 5 because they're not like radicals. They don't both have root 5. So what I have to do when I multiply these together is I have to FOIL them. So I multiply the 3 times the 2 because they're the first terms in each expression, and I get 6. Then I multiply the 3 times the 4 root 5, and I can multiply things that are non-like radicals. Remember, you multiply what's on the outside, and you multiply what's on the inside. In this case, there's nothing on the inside but the 3, so it's 3 times 4, which is 12, and the root 5 stays the same. Now I multiply the middle two terms, the insides, the 2 root 5 times the 2. Same thing. I don't have root 5, so I can't multiply anything on the inside, so it stays root 5, but the 2 times 2 on the outside gives me 4. So I have 4 root 5. Now I multiply the last term, the 2 root 5 times the 4 root 5. Again, when you multiply what's on the outside and what's on the inside. So 2 times 4 is 8, and 5 times 5 is 25, so that's 8 root 25. Now at this point, I hope you recognize that root 25 can be simplified into just 5, because the square root of 25 is 5. And that 5 times 8 is 40. So I have 6 plus 12 root 5 plus 4 root 5 plus 40. Now I combine like terms. I can't combine the 6 with the 12 root 5 or the 6 with the 4 root 5, but I can combine the 6 with the 40, and that gives me 46. And I can also combine the 2 root 5 terms. So I have 12 root 5 plus 4 root 5, and added together, 12 plus 4 is 16. So my answer is 46 plus 16 root 5. So I've multiplied these two radical binomials, and my answer is another radical binomial. So an interesting case when we multiply these radical binomials is the case of conjugates. So a conjugate is when you have the same two terms, only one has a plus sign and one has a minus sign. So in this case, 2 plus root 3 and 2 minus root 3. I said it's an interesting case, so let's see what interesting thing happens when I multiply these two together. So first I multiply the first terms, which in this case is 2 and 2 times 2 is 4. Then I multiply the outer terms, which is 2 times negative root 3, which is negative 2 root 3. Then I multiply the inner terms, which is 2 times root 3, so it's 2 root 3. Then I multiply the last terms, which is root 3 times negative root 3, and that's negative root 9. Again, you should recognize that negative root 9 is negative 3. So I have 4 minus 2 root 3 plus 2 root 3 minus 3. Now you'll notice that you have negative 2 root 3 and positive 2 root 3. Those cancel out, and 4 minus 3 is 1, so the answer is 1. Again, I said this is an interesting case, and this is interesting because I take two radical binomials, and when I multiply them together, I get a number that is no longer a radical expression at all, but a whole number. I'll even write that on the screen so that you can see what happens. So that idea that you can multiply two radical expressions together and get an expression that's not radical is going to help us when we have to rationalize denominators. Now remember, when we have a fraction, it's always wrong to lose a denominator in the bottom of the fraction. So I have to piddle some trick to get that denominator to get that radical, to make the bottom of the fraction, the denominator, not have a radical in it. And the trick we use is the trick we just learned. If I multiply by the conjugate of a denominator, I know if I multiply a radical binomial by its conjugate, the answer is going to be a whole number. It will not have a radical in it. So what I need to do is multiply this fraction, both the top and the bottom, by the conjugate of the bottom. So it's 1 minus root 5, and that means we multiply it by 1 plus root 5, but if we do that on the bottom, we must do it on top as well. So after we get this, we need to FOIL both the top and the bottom. And when I FOIL the top, I get 3 times 1 is 3, 3 times root 5 is root 5, root 5 times 1 is root 5, 3 times root 5 is 3 root 5, I'm sorry, root 5 times 1 is root 5, and root 5 times root 5 is root 25. On the bottom, I get 1, negative root 5, 1 times root 5 is root 5, negative root 5 times 1 is negative root 5, and negative root 5 times positive root 5 is negative root 25. Now on the top and bottom, both root 25s turn into 5. So on the top, I have 3 plus 5 when I combine like terms. I have 3 and 5 is 8, and I have 3 root 5 and 5 root 5 is 1 root 5. It's 4 root 5, I'm sorry. And on the bottom, I have the root 5s cancel out because one's positive and one's negative. So what I have is 1 minus 5, which is 4. So on the top, I have 8 plus 4 root 5, and on the bottom, I have negative 4. Now if I look at the top, both of those terms, the 8 and the 4 root 5, they both divide by negative 4. So I will do that. 8 divided by negative 4 is negative 2, and 4 root 5 divided by negative 4 is negative root 5. So my final answer, when I rationalize the denominator, is negative 2 minus root 5. That's my final answer. So here's the homework. I'm on page 92, 3 to 30 in threes. Good luck on that. This was lesson 3, so you should expect a quiz next class after we go over the homework. Okay, good luck on that quiz, and good luck on your homework, and I'll see you next time.